Hey class, I wanted to perform a quick illustration to drive home some points about data security and privacy. This is the spreadsheet we will be working with in this exercise. I'm sure you're familiar with spreadsheets. They are just collections of rows and columns. This particular one deals with student data and their GPAs. One of the major tools that I use at my job is called Python, which is a programming language. Python allows me to read in and perform operations on spreadsheets. To make things a little bit more interesting, I'm going to add a fake name and a fake social security number to each row. And this is actually a lesson in privacy itself, is that sometimes we can generate fake or synthetic data, and therefore we don't actually have to use the real world sensitive data. And this is commonly used, and there's actually a whole industry about generating synthetic data to ensure privacy and security. So I'm going to read in the file that we just looked at, the spreadsheet that we just looked at, and use Python to add those fake columns. This has now produced a file called student data with fake PII. PII is a term you might hear. It stands for personally identifiable information. And that would be something like a name and a social security number. Again, these are totally synthetically generated. This is not a real social security number. This is a totally fake generated name. This first row does not correspond to Jonathan Weber. It is just a name that was picked out of a hat and thrown in here. And again, this is not a real social security number. One of the first items we talked about was masking. So what I can do with Python is read in this file, take a look at it, and then say, hey, I want you to mask the name and the social security number columns. So let's take a look at what that does. So again, in our original data frame, which is what we call a spreadsheet in Python, we have the original values, but after masking it, we just have a series of X's. So if you were given a file like this and you wanted to ensure that you didn't actually have this information in your system, you could take it and mask it and then save over this file. So again, what I would do in the real world is, I would run this operation and then save over this file so that I still have the same information. I know there's a name and a social security number column, but I don't actually see those real values. We also talked about the idea of encryption, which is another way that we can retain security and privacy. However, with encryption, we create a longer scramble of numbers and letters for each unique value, and each value still retains its uniqueness. So a name like Micah Melling would have a different encrypted value than John Smith, and so on and so forth. And this has nice properties for performing certain types of count operations and also for merging data in different locations. So we can actually encrypt data in multiple places and still join that together because of this uniqueness property. So I'm going to use Python to create the encryption so we can see that our original file just has the raw fake values, but after the encryption, we see that each value is unique, but it's long and scrambled. And a fun fact is that this is called a one-way function. I cannot get from this hashed value back to this name. It only goes one way. It only goes from Jonathan Weber to this hashed value. I cannot get from this hashed or encrypted value back to this. And we won't get into the details of the mathematics of that, but there's some really interesting history of encryption and cryptography that I think is pretty fascinating. Another thing we can do is create a key so that we can then encrypt and decrypt the data. So let's see what this looks like. Again, I'm doing this all with Python. This is my original data. These are my encrypted fields. And then lastly, I was able to decrypt those fields and get it back to the original. So we can see that I'm running an operation called encrypt values. And then after that, I'm calling decrypt values with this key that I generated. So how this might work in the real world is that, let's say that I needed to send you data, but in the process of sending data, I wanted to make sure that I wasn't actually, over whatever protocol we were using to share the data. I wanted to make sure I was only transmitting the encrypted values. So if somebody intercepted that file, they would have no idea that this hashed or encrypted value corresponds to this person. It would just look like gibberish to them. So I could send you the file over whatever mechanism we've determined, and then using a second methodology or a second protocol, I could send you the key, and then that's, again, separating the lock from the key, if you will, that we talked about. And therefore, once you have both the key and the file, you can decrypt it to get back to the original value. But again, only people who have been given both the file and the key could actually decrypt this intermediary file. So that would be a way that I can more securely send data. If I can securely get the key only to intended parties, if they have the key and the file, they can then get back to this original value. But again, if the file were intercepted by a bad person, if they don't have the key, this is just going to look gibberish to them. And this is actually the way that a lot of internet security works. Again, we're not going to get into details in this short tutorial, but data over the internet is often encrypted. So if it is intercepted by a middleman, if they don't have the key that they need, it just looks like gibberish. And so this is actually the backbone of a lot of modern internet security. Lastly, I wanted to touch on fairness. So what I'm going to do is build a very simple machine learning model. And what I'm going to do is I'm going to take all the student data and use it to predict if they have a high GPA or a low GPA, basically. And I'm not doing all of the necessary data cleaning. This model will work fine, but what I should be doing is something called one-hot encoding to prepare some of this data a little bit better. I'm not going to dig into what that term is now, but that could be a fun thing that you could research on your own. Again, that's called one-hot encoding, and that is a way that we can represent categorical data to a machine learning model. But in this case, with the way the data is represented, we will still be fine. So if you recall, one of the fields in the file was ethnicity. So if I'm building a machine learning model to predict if the person had a high or low GPA, I want to make sure that my model is not unfair to any ethnic group. This would be something that would be really, really important to do. So what I can do is I can build this simple model and then use a framework to evaluate its fairness in terms of ethnicity. So I build the simple model, and then I can say by the ethnicity values of 0, 1, 2, 3, and I don't actually know what 0 maps to, what 1 maps to. I just know that these are different ethnicities. I can see that our model has slightly different accuracies in predicting did the person have a high or a low GPA. And so this is something that I might want to investigate. These aren't hugely apart, but there is a little bit of a difference, and this is something that I would want to understand and potentially correct for. So this could mean that I need to use a different model. It could mean that I need to do something with getting more data. It could be that I have a biased sample, so I need to rebalance my data. It could be that I have a wrong assumption in the data, so I need to throw out a certain column that I'm using. There's also the concept of constraining models with the concept of fairness. So we could say, hey model, I want you to maximize accuracy, but ensure that no group, in this case defined by ethnicity, has much of a difference in accuracy levels. So I can basically add constraints on my models for them to be fairness aware. So again, I know this covered a lot in a short amount of time, but I wanted to bring this to life a little bit and show some real world examples of how I actually implement security, privacy, and fairness in my job, and how that actually looks to a practicing data scientist.